Hello, I'm T.R. Bosworth. I'm one of the senior product managers on SUSE Enterprise Storage. And I want to give you a view for some of the futures we're working on around the hyper-converged infrastructure. So I'm going to talk about the open source way for delivering hyper-converged infrastructure. So put together a short agenda. We'll do a bit of an introduction on what hyper-converged means, a bit about the use cases. We're going to talk a bit about the growth patterns, how storage and compute fit together. Then we'll also talk about the open source building blocks. Also a bit about the deployment considerations, how we are going to have this journey occur for convergence of the open source components. And then we'll do a bit of questions, but we'll use those questions probably via email if you watch this and you want to follow up and get more information. So let's get started. So a lot of people talk about hyperconvergence and really what the promise of it is. You can see here in this diagram, the idea is it's a Lego block approach to scaling. So basically you incrementally add in nodes in the configuration and you scale both your compute, network, and storage incrementally in building blocks. So typically it's a very prescriptive sizing of these blocks of compute and storage, and it's using local storage with certain features that I'll talk about that people expect as far as performance and different things that allow them to use this hyper-converged configuration. So what I want to talk a bit about is some of the value that various customers and the market has seen around hyper-converged infrastructure deployments. So the evaluator group has done some nice studies that kind of have polled different customer sets on the various qualities that they value in hyperconverged. And you can see this is a comparison between 2017 and 2019 from left to right, you know, various things that people value: economics, performance, scalability. So I've kind of pulled out the top four. People are very interested in the economics of being able to incrementally add these building blocks into their configuration. Also getting good performance, having kind of a linear scaling capability, and also having the feature set that people have expected or have seen in traditional deployments of storage and compute. So this is what people tend to see, you know, typically value of HCI. So the same sort of questions were asked as what kind of use cases various customers and markets are seeing with HCI, hyperconverged infrastructure. Basically, the biggest use case obviously is consolidation, whether it's consolidation in a private cloud or consolidation of workloads in a big pool of resources. The second use case that people find to be the most popular is VDI, which is virtual desktop infrastructure. So it's it's virtualizing the desktop. And then databases, and then of course cloud. So as people build out clouds, they find HCI configurations very attractive from a planning perspective, and kind of using a single approach to build out their cloud. So we at SUSE have seen various use cases as well from our customers around hyperconverged. Typically, people either whether they're a customer building things out for themselves or they're a vendor that are using our technologies to build appliances for things like image capture and analysis. We've seen a lot of the telcos, when they're building out their 5G infrastructure, be very interested in this hyperconvergence, co-location of the network storage and compute on the same nodes and having a linear building block approach to putting together solutions. As the various strategies evolve around edge and core, many of the edge deployments, especially remote offices, various solutions for logging and analytics, the Internet of Things is quite active and growing. There's a lot of data being created in the edge around Internet of Things. And then, of course, if you collect something at the edge, you tend to also want to push it back to your core. So that would be either an on-premise private cloud, potentially when you're consolidating workloads, or even some of this is pushed out into the public cloud, depending on what people consider as their core. So this is kind of a view of where is the sweet spot for an HCI solution. You can kind of see that the diagram here goes from edge to core, and obviously the core is the data center on-premise, or it could be a core cloud. Sometimes people have edge data centers, kind of an aggregation edge where they aggregate data from the edge into like a common area, so that could be considered their edge. And then you can go all the way out to edge device or some kind of consolidating thing at the very edge in a device. So depending on what your use case is, it would depend on where the HCI solution would actually be deployed. But typically, from the requests that I've seen and what our customers are considering, the HCI deployments tend to be closer to the core and somewhat moving out toward the edge, but maybe not at the exact edge of their infrastructure. So it just depends on each deployment. So I want to just mention that open source obviously is the heart of what SUSE has to offer, but it's also the heart of what our software-defined infrastructure and application delivery approach is wrapped up in. And you can see that this is our view of our stack, and at the top we have our container and application platforms that we provide, orchestration built on Kubernetes from the Cloud Native Foundation Computing Group, Cubic, platform as a service with container application platform that's a Cloud Foundry distribution. And then as you move down in the stack, the software-defined infrastructure is built on the componentry from Linux, SUSE Linux with KVM virtualization, storage that is provided by Ceph and deployed with Rook on Kubernetes, networking that's built into SUSE Linux, and you can see some of the optimizations there with DVDK and OVS. And then basically the whole thing is anchored with our enterprise Linux offering as a multimodal operating system built on Linux. So all those things are kind of in the SDI stack, and then we have on the left-hand side we have the management stack as well, which gives you the ability to manage these things in a common infrastructure. So Stratos is our management that gives us the ability to manage containers across the various platforms. Prometheus and Grafana is built into most of our products so that you can get good performance monitoring and metricing across our portfolio. So this is a view of what is at the heart of our application delivery and SDI approach from SUSE. So let me focus in on the particular componentry that HCI, that we're going to build our HCI with, the building blocks basically. So at the top you can see Kubernetes orchestration, which is delivered with SUSECAS platform. So that's going to be the layer that's going to deploy and manage the containerized applications. And then KVM virtualization, which is built into SUSE Linux now, which will give us the ability, to manage virtual machines on top of Linux. And then Ceph storage, which is delivered with SUSE Enterprise Storage. So these components give you all the necessary things that you need to deploy an HCI configuration with storage, virtualization, and orchestration for containers. So this is what the SUSE Open hyper-converged infrastructure will look like. There'll be a HCI manager, and we'll have the same building block approach. So it'll be built with Kubernetes. This allows you to orchestrate compute, storage, and networking in a similar fashion, building blocks for hyper-converged. So you can see the first box there has cloud-native applications running in that particular node. The next one has VMs running, so that would be with KubeVirt, and basically you can mix and match the cloud-native applications and VMs in this configuration. And so you have that incremental scaling that you see that allows you to continually add in these blocks of hyper-converged infrastructure and either run VMs or cloud-native applications in your HCI configuration. So I want to talk a bit about the convergence of compute and storage and how we see that actually occurring. So you can see at the top here that Kubernetes is the control plane, and it's delivered with SUSECAS platform. And it's the area that takes care of the orchestration of either the gold pool, which is microservices, the blue pool, which is VMs, that's actually being enabled by KubeVirt, or the silver pool, which is SUSE Enterprise Storage, which is the storage componentry. So we have this software-defined infrastructure that's being controlled with the Kubernetes API for compute, storage, and network. So this allows you to converge the various components onto the same platform and have that that scaling that you have that I showed on the last slide. So you have the policy level settings in there and also service levels as well that you can set. So this is kind of an overall view of how this is deployed from a conceptual perspective. These pools of resources can be managed and deployed independently, and the microservices or VMs can basically use the storage that's over here in the silver compute pool. So one of the things to think about is how this ratio of compute and storage works, because you have, when you have this common building block in the hyper-converged infrastructure, you're kind of counting on that the applications are going to consume the ratio of compute and storage that you provision. So in this picture, you can see the application 1 has a particular application profile of its ratio of compute to storage. So the blue is compute and the red is storage. So if you look at application 2, it actually has the reverse of the block ratio. So it has a higher percentage of storage usage and a lower percentage of compute. So the point here is that the idea of hyperconverged works out really well if you have a uniform set of applications that you've planned for and they kind of match your building blocks that you're putting into the HCI configuration. Over time, storage or compute can be drastically different. So it's just something I wanted to point out, and we'll talk about in the next slide about some of the ways that you can actually configure the hyperconverged infrastructure to kind of accommodate this sort of difference between the ratio of compute to storage. So with Kubernetes deployment on Ceph, you have the opportunity to deploy it in what's known as a disaggregated configuration. So the disaggregated configuration is allows you to take some of the CES nodes and say, okay, I'm only going to run, or actually some of the Kubernetes nodes, and I'm only going to run Ceph on those nodes. So you're kind of dedicating various worker nodes just for storage. So that kind of gives you the ability to grow your storage independent of your compute. So the last slide kind of showed the ratio of compute to storage changing over time or between different applications. In this configuration, you can actually have your compute and storage all running in the same cluster, but you can kind of scale your compute separately from your storage or vice versa. So that gives you a little bit better quality of service to guarantee that you're getting good storage I/O response time, and it also gives you the ability to expand or contract your compute processing based on your workloads. So this is a kind of a hybrid, hyper-converged, disaggregated configuration with Kubernetes and Ceph. So this is something that you would consider if you had a lot of different workloads that were dissimilar and you wanted to give very good performance from your storage, and then potentially expand and contract your compute independent of your storage configuration. So having talked about disaggregated, basically going to a point where you're taking your storage and putting it on a few nodes and then having your compute separated. In this co-located configuration, you're actually dropping your compute onto the same nodes as your storage. So what you really need to be careful about here is when you do this co-located storage and compute, you need to actually plan for this so that you dedicate enough resources for the storage so that it's able to service whatever compute is running on that particular worker node. So you need to plan or pin resources for storage processing for performance, and also make sure that you have enough room there for your applications as well. So it requires a bit more planning. It'll work out fine. There's quite a few customers that have appliances and various things that they're working on where they really want to do this, and it fits their use case perfectly. So this is another option for this co-location of resources on a similar set of nodes. So one of the things that we are typically asked about these sort of hyper-converged deployments is just, how small can you go, or how small can you start before you start to grow, for instance. So this is a 3-node deployment is about the smallest that you can do. It requires you to co-locate the storage with the compute. And you're also co-locating your storage and compute with your Kubernetes master nodes. So one of the points there is you definitely need to guarantee that the resources for the key storage components and the Kubernetes masters have enough resources so that they're scheduled so that they're not starved for resources and causing performance problems. One of the things that we plan to do is qualify and test this configuration in the near future to give a reference architecture and definitions of what you really need to be careful with if you go super small with this. As well, there may be some documented constraints because when you go very small like this, we want to make sure that you have good performance and acceptable availability. So this is one of the areas where we're typically asked quite frequently about hyper-converged or co-located deployments of how small can you go. So this is the target for right now. And at the end, you'll have my contact information to be interested if you watch this presentation. If you have any comments about what your company is doing or what you're thinking about doing with very small edge deployments. So just in general, here are some security considerations for hyper-converged. Obviously, security is always important. Depends on your use case and exactly what you're doing. But we ship Cilium as one of the network capabilities within our Kubernetes in a container as a service platform. And that you should use that for policy control to separate your networks. You should also, when you deploy the networking for SUSE Enterprise Storage, that you have a separate network for the backend storage separated from the front end for clients. So that's a best practice, and that should help keep you secure around hyper-converged infrastructure deployments. The second point here is really about encryption. So you have the ability to enable encryption at rest, so when the data is on the disk, and also when it's being sent across the network in flight. So you should always turn that encryption on to keep your hyper-converged infrastructure deployments secure. The other point, the third point there is about AppArmor. You have the ability with AppArmor to apply profiles to make sure that you constrain the privileges that containers are given. So you're basically holding back the authority of particular applications and containers so that you ensure that no one gets root access or has more privileges than they require. HCI really is best around a single tenant. So since you're co-locating these resources on the same nodes, it definitely is the most secure if you have a single tenant, or if you have a tenant that all trust each other. So if you have someone in the same business unit, if you have someone that has the same level of trust and is sharing the same data, this works best for HCI deployments. I mentioned, I talked about disaggregated environments in previous slides about you basically dedicating particular nodes to storage so that you have better service levels and you can scale the storage independent of the compute plane. From a security perspective, if you use disaggregated environments, you're actually providing a better security posture because you're segregating those components to different nodes. So that gives you a better workload and tenant isolation perspective. So those are some considerations around security in HCI. So hyper-converged infrastructure really has some special expectations for storage. One of them is, from a performance perspective, is to have data locality. So that's saying that when you're running your application, whether it's a VM or a container, you really need to make sure that the data is available locally on the node that you're running your application on, because then you don't have to traverse other nodes to get the data and bring it back and not introduce more latency. So one of the things that with SUSE Enterprise Storage, you definitely need to enable local caching. And so that's definitely a recommendation. One of the things that's a work in progress in the community is to improve dynamic placement of the primary copy of data. So that's something that's being worked in the community to improve that picture. The other thing here is this replication to the core. So a lot of times if people are using HCI configurations on the edge, they're creating data, processing data, and kind of wanting to push the results back into the core data center for long-time archival or further processing or consolidation. So the S3 gateway that we ship with SUSE Enterprise Storage can basically mirror the buckets back to the core. So you can push the data back to the core automatically. You also have the ability with block RBD snapshots to do the same thing, and with CephFS you can synchronously or you can asynchronously replicate the file data back to the core. So those are some of the things that people are typically expect in that are there in this particular HCI configuration. So here's some best practices for hyperconverged storage when you're deploying a co-located or hyperconverged configuration with SUSE Enterprise Storage. So you always want to have the fastest disk possible. So we prefer SSDs or NVMe drives over hard drives that are spinning drives, just to avoid contention. So since you're intermixing the compute and the storage on the same nodes, the faster the storage drives are, the less potential contention that will show up in latency. So these hyper-converged infrastructure deployments are very sensitive to latency, and since you're not dedicating the resources to serve storage, you need to use higher speed drives, which the SSDs and NVMe are much faster than regular spinning hard drives. The other thing that you really want to do to improve the performance is use low latency, high bandwidth networking. So really preferring 25 gig Ethernet or better. So that's back to the same story. Since you're intermixing compute and storage on the same nodes, you want very high bandwidth and low latency networking options to improve and keep the performance really, really good. The third item there is around replication. So it's much more efficient, and you'll get better performance out of the configurations if you're using replication versus erasure coding, especially on small scale deployments. Another point that's worth bringing out is it's really good to turn on all the automation that's available in SUSE Enterprise Storage. So as an example, the PG Autoscaler and Balancer you can set them up, basically that turns on automation, and it makes it much easier to operate, and it'll work better for you in general. So I've kind of talked about how we co-locate storage and compute on the same nodes. So as a result of that, you definitely want to provision adequate CPU, memory, and networking resources for each of the components. So you want to give dedicated resources to the compute side of things, and also dedicated resources especially to the storage. So that's one of the best practices that you definitely want to follow. So what I want to talk about, and you can see that this is a forward-looking statement and can be subject to change, but this is kind of a picture of the components that I've talked about, what's available now, and what's going to be delivered in this year and then beyond. So right now, we have SUSE Enterprise version 6 in the market available now, and Container as a Service Platform version 4. So these releases allow you to co-locate the compute and storage now, and that's available for cloud native applications. So you can take a containerized application, you can run it in Kubernetes in cloud or in Container as a Service Platform version 4, and you can consume SUSE Enterprise Storage, which is a Ceph offering. We have a technology preview in version 6 of SUSE, which allows you to deploy Ceph using Rook, which is part of the tech preview, on top of Container as a Service Platform. So you're running Ceph as an application, containerized application on top of Container as a Service Platform. As well, in CAS version 4, we have a tech preview for Stratos management, and Stratos is a management layer that allows you to deploy containerized applications and monitor and see get a consolidated view across multiple Kubernetes instances, so you can see what is going on with your application. So that's available now. With SES 7 and CAS 5 later in this year, we'll have full production support for Rook. So we'll be able to deploy Ceph, which is SUSE Enterprise Storage, on top of Container as a Service Platform, which is Kubernetes, and we'll have full production support for that with Stratos. One of the things that we're looking at in 2020 is to bring out a technology preview so that we can run the VM workloads on the same Kubernetes infrastructure using KubeVirt, which is the enabling technology to run KVM and run VMs on top of that within a Kubernetes infrastructure. And then you can see out in 2021, bringing in production support for KubeVirt and Container as a Service platform, working in the community to basically improve some of the algorithms that I talked about with data locality for storage. We're going to bring in some actual SUSE packaged HCI offerings, and which would also include a manager for the hyper-converged infrastructure. So we're going along, we're developing the different building blocks, and in 2021 we'll have full production support for all of those, and we'll have packaged offerings around this hyper-converged infrastructure. But we have customers now using SUS6 and CAS4 to do co-location of storage and compute. And we have people using the technology previews for SUSE Enterprise 6. And we have a lot of interest in what we're bringing out with SUS7 and CAS5 around full production support. So I'm very excited about this. We're doing basically a stepped approach to delivering the SUSE HCI componentry over time, but this year will be a key year in our delivery of the HCI componentry. So these are some of the packaging options that we're actually looking at. You can go from a pure appliance to some sort of an OEM where you get an appliance from a original OEM manufacturer. You can go to a reference architecture. You can do software only. You can see kind of the pluses and minuses. Obviously, if you have an appliance, you have a single vendor, maybe quicker time to value. You're kind of locked into the hardware and software that the appliance brings. An OEM, you know, gives you more value options. A reference architecture is much looser. It just is saying, okay, if you want to use this particular vendor's hardware, this is how you set it up. And then, you know, software only is basically, okay, you get this group of software and you can deploy it on, you know, any kind of hardware that you're interested in. And typically, at SUSE, we're using the YES certification to basically mark those different hardware components to say, yes, this works with basic SUSE Linux plus these other components. So these are the things we're considering. We'll for sure do a software only package, and for sure we'll be doing reference architectures with various vendors, hardware vendors that we work with. Whether we do the OEM and the appliance is really based on some of the market feedback that we get from our customers and partners. So I hope that this session was useful. I kind of gave you a picture of where we are, what the components we're using for a hyper-converged infrastructure, and then kind of the progression or the steps for the future of how we plan to deliver these to the market. If you have questions, please reach out to me on email. I would be happy to get any input you have, and we'll definitely answer your questions. So I hope you have found this to be interesting, and thank you for attending this virtual session at SUSECON. Thank you.